Another fascinating aspect of your research is that it tells you about learning and what is actually happening in the brain when we're learning. Can you talk a little bit more about that? What's going on in the brain when we learn?
Yeah, so that is the question that I was fascinated with when I got to NYU and wanted to know, because I was fascinated with it because we knew that this key structure important for memory called the hippocampus, that structure was really important for learning fast new kinds of information. Just sometimes you can learn things on a single trial and it would last for a long time. How does that happen? And what happens to the cells, the brain cells in the hippocampus as you are forming these new memories, these fast new memories? Not memories where it takes you, 50 trials to learn something new, but fast new memories. And so what we did is we asked animals to learn new associations, new combinations of things, and simply recorded the cells in the hippocampus as they were learning these things. Basically, we were having them play video games, memory video games. And what we found is, and I'll never forget hearing this for the first time, when you're recording from these cells, you can actually hear their activity. And brain cells communicate by brief bursts of electrical activity called action potentials. And on an audio monitor, it sounds like a little pop. So this little electrical pop. So it's pop, pop, pop. And I was recording from a cell as an animal was learning something new. And the cell didn't care. It was just kind of randomly firing, couldn't tell what was going on, until I noticed that the animal started to learn one of the associations that we asked him to learn. The specific association is we would give him a picture of a dog. When the dog came up, he would have to learn that it's the north target that would get him a reward. But when the cat came up, it was the south target. So he had to learn these different associations. So let's say he started to learn the dog association. And just at that time, I heard that cell start increasing its activity, where before it was kind of random. Every time that dog came up, the cell started really firing like mad. And I thought, that is interesting. And once I noticed that, I realized that in fact, in about 20% of the cells in the hippocampus, you can see cells start from nothing, no relationship if they're firing activity, until the animal learned something, not anything, a particular thing. And then that cell would start to fire. So what does that mean? That means that, for example, if I learn your name, your first and last name. So at first, I'm not going to remember it. Too complicated, don't remember it, and the cells in my hippocampus are not doing anything. But once I learn your name and I get it correct, I will have a not just one cell, but a network of hippocampal cells that will start to fire specifically to that learned piece of information. That's what we started to realize as we were doing these recordings, that we started to see this network of cells come online as new things were learned. And nobody had that view of new learning in the hippocampus before.
And what's the benefit of that when they all come together like that? What's happening?
That's a great question. The benefit is that you form a kind of coherent network of cells so these cells have just basically formed new connections between the dog and that particular target. And that is the basis, that network and that firing activity is basically your brain basis of that memory. That is the physical instantiation of what that memory is. And we're still trying to understand how that works and how does that last then for 90 years? Can we see it lasting for 90 years? Those are very, very difficult questions. But what I identified was basically the brain signature of the birth of a new memory.